Here, in this last example, we want to show that this piecewise function is continuous and differentiable at x equals 1. So we must show that the function is continuous first before we can show it's differentiable, because if it's not continuous at 1, then there can't be a tangent line at 1. So we're going to check for continuity first. And this goes back to unit 1. There's 3 steps. First, we find f of 1. That will use our top function, which is 2. Then we check our limit as we approach 1 from the left and from the right. From the left, I use the top function again. That gives me 2. Then I also have to check the limit as we approach 1 from the right. That will use our bottom piece, which is also 2. So remember, together, this shows us that the limit as x approaches 1 of f of x is 2. So last step, f of 1 equals the limit as x approaches 1 of f of x, which is 2. Therefore, f is continuous at x equals 1. Now that we know that f is continuous at 1, we know that there can be a tangent line there. So let's see if it is differentiable at 1. So now we're checking differentiable. Does the derivative exist there? So first we need to find that derivative of this piecewise function. The top piece becomes 2x, and that's for x less than 1. The bottom piece becomes 2, that's for x greater than 1. And now we need to figure out what is going to happen here for x equal to 1. Okay, so keep in mind the definition of a derivative is the limit of the average rate of change as the distance between the two x values gets closer and closer to 0. So for this derivative to exist, the limit from the left of the derivative needs to equal the limit from the right of that derivative. So the limit as x approaches 1 from the left of f prime of x will be 2 times 1, which is 2. The limit as x approaches 1 from the right of f prime of x is 2. Therefore, the limit as x approaches 1 of f prime of x is 2, which tells us that f prime of 1 is 2. So we can say f is differentiable at x equals 1. And we know that its derivative at 1 is 2, because the limit of the slope from the left and the limit of the slope from the right both equal 2.